Hi, my name is Han Tao. Today I will present my final project, which is forecasting advertising success. More specifically, we want to predict the impact of bank advertisement on customer behavior. Our project will split into 5 parts. The first part is introduction. Basically, our project is a binary classification with 17 features. With 17 input features, we want to forecast the success of bank advertisement and predict the impact they will have on customer behavior. And our data set came from UCI Machine Learning Repository. Here's the link. And this is the data review of our whole data, which has 7 numerical data and 10 categorical data. For the second part of method, we basically apply 6 models here, which includes linear SVC, logistic regression, decision tree, random forest, gradient boosting classifier, and KNN classifier. For the third part of feature selection and engineering, we first describe the numerical data. Here you can see that our data has lots of outlier and very high skewness. In fact, in the first time we want to use normal IQR to exclude some the outlier. However, in fact, using normal we will exclude more than 50 data here. And furthermore, the IQR methods may not be appropriate for certain types of data distribution, such as those with heavy tails and skewness, which is exactly aligned with our data distribution. Based on the above reason, we control the exclusion range within 10% to 90%, which means that the IQR here is redefined as 10% to 90%. And we also describe our categorical data here. You can see that our whole data is a very imbalanced data with the ratio of 88 to 12. We also apply correlationality analysis. Here we drop one of our features, which is P outcome, for the reason that it has a very high correlation with the 2 other features here. So in the following analysis, we don't use these features to do the prediction. The fourth part is our models. Basically, as we say, that our whole data set is a very imbalanced data. So we apply 5 different methods to deal with imbalanced data set. The first is class weighting. Here we will use logistic regression and also undersampling, oversampling, smooth. It is a very unique methods to deal with oversampling. And also in sample method, here is the gradient boosting classifier. First, we apply class weighting, which is logistic regression. However, we found that it is very weird and the outcome of logistic regression with the setting way to balance is much lower to the logistic regression without that setting. Here, we may think that since the minority data is very small, it has a very small ratio in the training data set. So when you manually set the parameter weight to the balance, actually it will enhance the accuracy of the logistic regression. And the ratio of 2 class here, the initial ratio is 88 to 12, which is 0.136. And here we don't know about the perfect ratio we want to use in our future model. So we set a range of potential ratio, which is the range of 0.2 to 1.1 with the step of 0.1. Here's the highlight of our model. First, we have the X train and Y train, the original data, and we use different imbalance solution and different potential ratio to get a lot of X resample and Y resample. And we model with grid search CV and to find the best parameter. And after that, with the best parameter, the model will fit the X resample and Y resample. And we will use classification report to evaluate the model performance, since the simple accuracy score cannot tell us about the performance of minority class. And finally, we will find the model with the best performance. Here, with the best performance is predicted by random forest classifier with imbalance solution smooth, sampling strategy equal to 0.2. We found that the accuracy for minority data is 62, which is very high, and the general accuracy is still very high, is 0.191. So about our conclusion, first, after data preprocessing, we're using resample data set with different imbalance solutions and sampling strategy to train different model, and we get the best result of random sample smooth sampling strategy with the model of random forest classifier. And sometimes we find that the linear SVC outperform the others, but the result is not consistent, which means that when I redo the model, it doesn't give the same result. So this is quite weird. For our future improvement, we want to enhance the imbalance data handling. For example, we can apply like cost sensitivity method and other kinds of like imbalance solutions. And also we want to expand our ensemble method for the reason that we only use gradient boosting here. So in the future, I would like to use another like stack boosting. And third is that we can utilize additional algorithm like neutral network and space vector machine. So that's basically all my percent. Thank you.